Okay, class, we continue our lecture with chapter 2, stoichiometry. So for ionic compound, the term formula mass is used and the number of atoms of each element inside the parenthesis here, inside the bracket ataupun kurungan, is multiplied by subscript outside the parenthesis. Okay, first to find the formula of mass of barium 2 nitrate, first 1 times AMU of barium plus 2 times 1 times AMU of nitrogen plus 3 times AMU of oxygen. And you get the answer 213.32 AMU. And for the percent composition of the compound, a practical use is to determine the amount of an element in any size sample of compound, and the mass percent of element X is equal to the number of mole of X in a formula times the molar mass of X gram per mole divided by gram of 1 mole of compound times 100%. And this is the sample problem. In this question, it states in mammals, lactose is metabolized to glucose C6H12O6, the key nutrient for generating chemical potential energy. What is the mass percent of each element in the glucose? And number B is how many grams of carbon are in 16.55 gram of glucose? And the answer is, for A, you need to find the mass of 1 mole of glucose first. How to find the mass of 1 mole of glucose? Okay, this is the RMM for carbon. So times 6, because here you have 6 carbon, plus 1 times 12, because here you have hydrogen, 12 plus 6 times 16. Then you get 180.16 gram. And after that, to calculate the mass percent of carbon, hydrogen and oxygen, mass percent of the element X equal to the mole of X in formula, which is a 6, here is 6, times, this is the RMM for carbon, divided by the total mass, here is molar mass, gram per mole, total is 180. So you get 40 mass percent carbon. Same goes to hydrogen, is 12, because here is 12 times 1 divided by the total mass here, total RMM of this, all the compound in the glucose, times 100%. Then you get 6.714. And for the mass percent of oxygen, 6 times 16 divided by 180 times 100, then you get 53.29 mass percent. How many gram of carbon are in 16.55 gram of glucose? First, you need to find the mass of carbon. To find the mass of carbon equal to the mass of glucose times mass fraction of carbon. Then you need to cancel out this unit. Then you get the mass of the carbon is 6.62 gram carbon. And for the mole, what is the mole? Mole is the amount of a substance that contains as many entities, atoms, molecules, ions, as there are atoms in 12 gram of carbon, 12 atoms. Okay, 12 gram carbon 12 is equal to 1 mole contains to 6.03 times 10 to the power of 23 carbon 12 atom. And And for the 1 mole of sodium, it also contains 6.02 times to the power of 23 sodium atom. And for water molecule also contains 6.02 times to the power of 23 water molecule. Also same goes for 1 mole of car and 1 mole of carbon 12 atom. Okay, to converting moles of element. Okay, to convert between mole and mass, use molar mass. Molar mass, the unit for molar mass is gram per mole. To convert between mole and number of entities, use Avogadro numbers here. To find the number of the molecule in a given mass or vice versa, convert to mole first. Okay, basically this is the method, the flow chart on how to converting moles of compound. Okay, for example here, find the mass of 0.5 mole of copper. So this is the molar mass for copper is 60.55. So the molar mass of copper is 63.55 gram per mole. And to find the mass is you need to times with the mole. 0.5 times with 63.55. Then you cancel the unit mole and mole. Then you get the unit for gram, which is referring to the mass. And this is the sample problem for tetraphosphorus decaoxide. P4O10 react with water to form phosphoric acid. What is the mass of 4.65 times to the power of 22 molecule of tetraphosphorus decaoxide? And this is the molar mass for each atom for phosphorus and oxygen. And B is how many phosphorus atoms are present in this sample. So for the mole of phosphorus P4O10, this is the number of the molecule times in the 1 molecule of this tetraphosphorus decaoxide. It contain around 6.022 times to the power of 23 molecule. Yang ni dah kamu tahu diberi. Tadi kan saya explain kan. So you cancel the unit, then you get this answer. And for mass of P4O10, tetraphosphorus decaoxide, to calculate this one, you need to, in the 1 mole of P4O10, how to calculate this one? So you cancel the unit, how to get 283.88 gram. So you get this answer. Okay, please find by yourself how to get this one. Okay, basically 283.88 is the molar mass for tetraphosphorus pentaoxide. Here, 283. Okay, how many phosphorus atoms are present in this sample? And number of phosphorus atom, 4.65 times to the power of 22 molecule times 4 atom. Because in this formula, it has 4. In 1 molecule, it has 4 atoms. So you cancel the unit molecule and molecule, then you get 1.86 times to the power of 23 phosphorus atom. For the chemical formula, chemical symbols used to represent atoms of the element that are present. Element symbol and numerical subscript show the type and number of each atom present in the smallest unit. For example, if you see the H2, it composed of 2 hydrogen atom. Here is it composed of 1 sodium atom plus 1 chlorine atom. And here, this molecule composed of 2 aluminium atom plus 3 oxygen atom. And type of chemical formula, there are 3 types of chemical formula: molecular formula, empirical formula, and structural formula. For the molecular formula, so it normally describes the exact compound of the molecule. And for the empirical formula, it normally gives the smallest numbers that describe in the ratio of atom in a substance. And for the structural formula, it normally describes the position of atom in the molecule. This is the structural formula because it shows the arrangement of the carbon and the hydrogen in the structure. And here is the empirical formula. It normally shows the simplest formula, and this is the exact formula for benzene. Relationship between the empirical and molecular formula. So for this is the formula, molecular formula divided by empirical formula. So the empirical formula and the molecular formula of the compound could be the same. For example, ammonia and carbon dioxide. And 2 molecules might have different molecular formula but same empirical formula. Normally, benzene has the same empirical formula, but the molecular formula is different between the benzene and ethine. Benzene is aromatic compound, while ethine is triple bond. What is the molecular formula? In order to find the molecular formula of a substance, 2 pieces of information are needed. Maksudnya untuk kamu cari molecular formula tu, kamu kena ada 2 maklumat. Pertama ialah percentage composition, di mana kamu dapat daripada empirical formula, dan molecular weight ataupun mass. And the molecular weight ataupun mass allow us to choose the correct multiple of the empirical formula for the molecular formula. Maksudnya kamu kena dapat dulu empirical formula, baru kamu boleh dapatkan molecular formula. So yang ni adalah dia punya flow chart untuk kamu kira last kali macam mana you dapat empirical formula. And then this is the example of the question. Okay, to calculate the empirical formula from mass of constituent. So here the question state 18.3 gram sample of hydrated compound contain 4 gram of calcium here. So basically this question you need to write down in a table to make it easy for you to identify the unit and also to differentiate between the mass amount and the ratio. And then you make a table that contain 4 columns here. Constituent consists of calcium, chlorine and water. And for the calcium, the mass is referring to 4. Chlorine is 7.1. Water is 7.2. And you need, the question asks you to calculate the empirical formula. So how? Okay, from here, from mass, you need to divide by 40. 40 is referring to molecular mass of calcium. Then you get 0.1. Same goes for chlorine. 7.1 divided by 35.5 is also 35.5 is referring to molecular mass. And here is also molecular mass for water. So you get 0.4. Then among this amount, mole, 0.1, 0.2, 0.4, you need to choose the smallest amount. So 0.1 is the smallest amount if we compare to 0.2 and 0.4. So we choose this value. So from here, 0.1 divided by its own value, you get 1. So 0.2 divided by 0.1, you get 2. And 0.4 you divided by 0.1 you get 4. So the simplest ratio of relative amount, the empirical formula is calcium is 1, Cl is 2, and the ratio for water molecule is 4. So you need to write like this, CaCl2 dot 4 H2O. And here is to calculate the empirical formula from percentage composition by mass. Okay, here is ascorbic acid, or we call another name is vitamin C. So it contains of composed of carbon, hydrogen, and oxygen. And the molar mass of ascorbic acid is 176 gram per mole. Okay, the molar mass. This is the molar mass. Okay, here is a 40.92, 4.58. So you take this value, and here is oxygen. You take this value, 54.5. So to calculate the mole, you take the formula. So how to calculate the mole? Mole is equal to mass over molecular mass. So you take mass here, 40.92 divided by its molecular mass for carbon is 12. Then you get 3.4. Same goes for hydrogen and oxygen. Then after that, you need to choose the smallest amount. So referring to this row, the smallest amount is 3.41. So 3.41 divided by 3.41, you get 1. Here you get 1.34, here you get 1. So here should be 3. So 3, 4, and 3. So this is the decimal. Decimal, if half is 0.2 is half, 0.24 is 1.5, 0.33 is 1/3. Okay, later I will explain to you why it's get 3, 4, and 3. Okay, that's it for today.